Greetings and welcome back. Today we are going to do data analysis using SAS University Edition. I have a tutorial that teach you how to install SAS University Edition in another video. That video is linked below and also in the card description above. So check out that video first, fire up your SAS University Edition, and let's crunch some numbers. Let's do it. All right, so this is the data set that I'm going to analyze. The student sent to me. As I mentioned, there are two type of data. One is text. This has to have denoted by the $sign in the SAS code, and the numbers. So make sure everything is correct, everything is the same, because if you add only one letter here, SAS will treat it as a paired variable, just to make sure everything is okay. Also, this is my data. All right, so always good practice to check your data, and I usually use conditional formatting for that. And I see why this is higher. I go back here. Okay, this is the data for the peel. That's why they are always consistently higher than the pulp, and this goes throughout. I also check here. This is where you find small mistakes, like when you forget, for example, when you forget a small decimal point, when you add a number by mistake while typing. So it's always good practice to check your number if everything is okay. So you probably see this is consistent, the data is homogeneous, there's no outliers, and so on. So that you do to just clear up your data sets. Otherwise, everything seems to be fine. Once that is fine, remember, we will save this as delimited comma separated value. This is one of them, my value. So this is going to be the banana oil data, right? So and then one small thing is you need to make sure that you save this in the corresponding file in the drive. That's where you saved your data file. So for me, I saved my SAS data, SAS University Edition, in my folders, and this is where I had it saved. So it's going to be here. So it's always better to have a new folder for each data, because that will save you time and trouble later on. Okay, so this is banana data, and it's saved there. That's all. Obviously, this is not going to be an Excel sheet. Do a double check. You go here, and then you go your SAS University Edition to make sure your data is saved and in the format that you would like to SAS to read them. So here we go. This is what it means to have comma separated value. That means they are separated by comma and they are delimited by comma. And so that's what SAS needs to know. The first row is the titles, and I got that from so this row is title row, and SAS is going to start reading from the second row, and that's what I will say in my code. It's very important. If you don't have this, then you start from the first observation. If you have another column or another row, then you start from the third row. But usually this is how it looks like. So now my data is converted, it's ready. All I have to do is set up the SAS code. Okay, so here is the components of SAS and my code. I'm going to go through it one by one. Basically, as I mentioned before in the other video, which you will see in the link below as well as in the cards above, that the SAS University Edition has this interface. The components are, this is where the code is, and then you have the log. If there are any errors, any warnings, any notes, they will show up in the log. It's always good practice to look into log. Then we have the results section where your results from the code will show up. Okay, this is the data that I already had there. I tested to see the data that I imported to SAS. It's all here. So this is my code. So basically the code is made of these components. The first thing is the title. This is the title of the code. This is what you name it. You can name it anything. And of course you could have colors and all of that I showed you in the previous tutorial. What I am always interested in, just to give it a clear title to show what the title of my data set or analysis is, because this will show up in the output. So you could do anything here. You can even have numbers. For example, this is banana oil data. For example, you can call it number 1. Between these comments, you could have anything. You could type anything as a title. So that's the first part. The second part is the name of the data set itself. Okay, so my data set name is banana data, and you will have to repeat this that you will see everywhere. So if you highlight this, you can see it's everywhere highlighted. That's already referred to the data sets that I already had. Where is the data itself? It's here. This is my data. Okay, so I told SAS where my data is. It is in the file, which means here in my folders. And so I created a folder called banan data, and I placed my data set there, and the file itself that I converted as a comma separated value file is banana oil, the one I showed in the previous step. Separating the data with a comma, and I asked SAS to start reading the data from the second row, because the first row is actually, you can see here, the first row is the title of my data, which I need. So it starts reading from the second row in Excel sheet or in the dataset that I already submitted, or SAS will read. What are the variables? The variables of the data sets is varieties, temperature, sample, treatment, potassium, sodium, and calcium. So this is called variable. These are the input variables. And then always you say run. And one more small thing is, after run, you have to semicolon. This is always a mistake that always creates problem for most people. They forget the semicolon. It has to be semicolon. So I am basically telling SAS that my data is in here in SAS University Edition, in my folders, in a folder called banan data, and it is here. This is what I'm telling SAS now. This is my data. This is exactly what I'm telling SAS. The top is a header. Don't read it. You start reading from the second file, and you will be able to see this as comma separated file. This is how it looks like. So this is the first row, and this is my data. Okay, so that is exactly what I told SAS in this part. So this part is basically the data name and location. So I'm done with this part. To check that SAS actually reads properly my data, I ask him to print out the data set. How do I do that? This is my first procedure. Data deals with procedures, so every procedure starts with PROC, P-R-O-C, which means procedure. I only ask that SAS here to print the data set. So I ask data print data equal to what I named the data previously, which is banana data, and then run and semicolon. That's all I need to do. So actually I can actually stop here. Okay, and then I will see what SAS will tell me, and comment out, as I mentioned before, comment out everything below this, because we'll come back to it later, step by step. Okay, so now what SAS will run only this procedure. So then you go run here. Okay, see SAS now run the procedures. This is very important to check that your data is actually imported properly and it is the same, because if you don't type the code properly, like you would see here, that this is a text and this is not a text, this is a number, numerical value, and this is a text value, then SAS might be confused and you'll get the wrong results. So it's important to check that using the print syntax here, procedure, print procedure for the data to make sure just everything is right. And then you compare this to the data that you have already before, like here, to make sure that these numbers are actually the same and your data is imported properly. And so I always do this to make sure, like, okay, here are my numbers, 7,200, and check here 787.5, so everything looks fine. So I'm now happy and making sure that SAS actually did what's supposed to do. Again, you need to check out if there are any errors, anything. Here there are no errors, these are only notes, so it seems like everything is executed properly. Now I am relaxed, I'm done with this step. Once you are done with this step, you can close it. You can also comment it out because you have done this part. Khalas, it's done. That means you don't need to do it again, it's finished. You go to the next step. Next step, I would like to see summary statistics of my data set. And so I can use different ways. I'll show you 2 different ways to do this. This is one way, which is will be showing you in columns. And actually what we use is Brock means always for this purpose. So here we have the procedure. By the way, SAS does not care if you have capital or small. So here I will say that, for example, change it from small to capital, but it doesn't really matter. So the mean here will give you the standard, the mean, the standard deviation, standard error, the minimum, the maximum, anything you would like, you have it here. Okay, and I need to tell SAS I need this for these variables. You can have one, you can have, for example, just one, potassium, for example. You don't need sodium or calcium, or you could have them all. I need to tell SAS here what are the classes are, what are my basically treatments, what we call treatments, or controlled variables. That is the variety, the temperature, the sample, and also the treatment. Okay, so this is very important. Here we have everything, but we know in our data set that these are our variables. Okay, and this is the data that we got after the analysis. So that I need to tell SAS that information here. Alright, so let's run this one. Here we go. There's my table. SAS executed the means procedure, and it is showing me the mean, standard deviation, standard error, minimum, maximum, and n for each one. Because you have only one data set, because I sorted it out by all the small details, like one by one. So of course there are no averages here because it's just one observation per all these variables. But if I go here, for example, and I say forget about the treatment, and then run again, there you go. Now you have excluded the treatment, so that means each sample will have more than one sample. Then you have the mean, standard deviation, standard error, minimum, and maximum, and you have 3 samples. That's why you got all these details. So here you can play around with your data and explore the average, and this gives you a good information, and also set up tables in your data sets later on. So that is done by the Brock means. Another way to do this, which is very similar, still the same, Brock means, this is descriptive statistics too, so this is another way to do it. I will post this code at the end below in the description, so you can copy it and try it out yourself, but have your own data sets if you like. So here is, you can see here, I sorted it by variety because I am now interested only in variety. You can do this grouping in 2 ways. One is this by, also you can have it here the same way. You can have by variety, even in the previous code here, the one I showed you just now. Or you could have it this way, the same story, but first I sorted it by variety, and then I added the same procedure, Brock means, and I included what I'm interested in, which is basically the mean, standard deviation, standard error, and by variety. This seems to be easier, but this is another way to do it. And these are the variables, the same thing here. These are same variables here. So this is going to give me the same output, the same results. So here we go. We run it now, and we check the error. There are no errors there. And this is my data sets now. This is one way to do it, and this is the second way to do it. Okay, but this is sorted by variety. So this is for Cavendish, and this is by milk banana. So this is Cavendish, and this is the milk. Okay, so the difference here is this is sorted out column by column. Here it is all combined. All the data is combined. That's why it looks different. So this mean includes all data related to potassium sorted by the variety. So this K under all conditions, under all treatments. Here it is sorted out by treatment. So you have the variety, you have the temperature, you have the sample, you have the treatment, but also by variety. This is one variety, this is the second variety. So what happens here is that it combined all this data, and gave you this average, which basically the average of all these data that is here. So it's the average of all the data sets, and that's how they are different from each other. So you have this way, and then you have another way that combines all the data. All the data is classified or grouped for each treatment. Try this out and see how you can get your means, standard deviation, and standard error for your data in these two different ways. Okay, now we are done with this. That's it. We just comment it out. As always, myself, I like to comment out anything that I don't need in the code, so I can easily follow the rest. Now we will go to the next step, which is the ANOVA procedure, which is basically, that was the summary statistics. Now the ANOVA. The ANOVA procedure, there are many ways. As you know, there's one-way ANOVA, two-way ANOVA, GLM procedure, there is a mixed procedure, there's ANOVA procedure. What I use usually the GLM procedure, which is satisfactory to my needs. And there are certain conditions where I use one or the other. You can read about that. But now I want to show you only how to code it. So I use a procedure GLM, the same data set, banana data, my data. Remember, the classes are the same, except that I remove the $sign, because here you don't need to tell SAS to read the data. Basically, you tell the classes what are the classes are. The same thing like we did in the proc procedure, like the one we had before. Like here, the same thing. They are the same. And then I tell SAS what to analyze. The same thing like we did with variables here. The potassium, sodium, and calcium, which are dependent on what? So these are the independent variables. These are the dependent variables, which is the variety, temperature, SAM. This is independent. This is the one I control. So this is the one independent that are the output, the readings that I had. So here is the variable or a variety, temperature, sample, treatment, and I am also interested in the interaction of variety and treatment. So I added this code to show me interaction. You can add any kind of interaction. For example, if you are interested in variety, for example, by sample, to see if I take from a peel of different variety will be different or not. So it's going to be all here. And I also take this interaction, I add it here in the ls means to get mean separation for the interaction. This means will give me if there are significant differences, okay, this model, and then it will do mean separation using the Duncan procedure. There are different ways to do this. There are 2 key, and there is Duncan, and there are LSD, and there are different variety of procedure. You choose the one you are interested in, and this is where if you are interested in 2 key, then you just say 2 key here. If you are interested in Duncan, then you add just Duncan or LSD or whatever. So this depends on your choice of mean separation. That's it. This will give you the ANOVA output, complete with the interaction and the mean separation. Of course, usually this is post-hoc. That means if this is significant, then you go to this step. But here, for the sake of simplicity, we are going to do it all at once. Here is running now. Remember the run and the semicolon is always important to have. Here is my GLM procedure now ready. I think we are all set. We don't see errors and all of that. Here are my varieties, 2 of them, temperature and the sample and the treatment, 3 treatments. So everything seems to be working. I have 24 readings per for my data sets. And then here is the analysis itself. And this is my ANOVA table for potassium. So the data set says, oh, there are differences somewhere between treatments. Okay, so that means I need to go further down and see. Usually these will be different if there are differences, type 1 SS or type 3 SS. If there are differences in there is missing data or there are unbalanced data sets, then it's going to be shown here. But because my data is balanced, I have no problem. These two are actually the same now. So here is my treatments. It says here there are differences. I need to know where those differences are. So here is where to look for probability. Okay, now it shows already there are differences in potassium content. Remember this potassium, huh? Between varieties, but also between temperatures as well as between samples. But my treatments were not different. So the treatments that I had, which were 3 right here, were not significantly different from each other, as you can see here. How about the interaction? The interaction was not significant between variety and treatment, but between variety and samples were significant. So that is an example of interaction, and this is an example of independent variables, or variables that are actually my treatments. So now I could see this is good news because I already have significant differences in the concentration of potassium in relation to variety, temperature, sample, as well as there is interaction too. So let's look now at the next sodium. Sodium is different too in variety and also in samples, but you can see it's higher than 0.05. So the difference due to temperature is not in the sodium, as well as the treatments are not different. Calcium differs in response to temperature as well as in samples, but not in treatment and varieties, and of course that's also expected not to have a difference because of that in the interaction, but the interaction between variety and sample is significant here. Okay, so this is we're still in the GLM procedure. Now we look at the graphical distribution, which shows us the mean separation here in this case. We use Duncan multiple range test for potassium, and you can see that Cavendish has more potassium than milk banana, and you can see also in graphical format. How did I get this table? Because usually you don't get it. I added in the code lines table. So this lines table here showed me that table here in the output, the grouping, Duncan grouping based in a table, and it shows me the mean as well. So if you wanted this table, you add lines table in your code. Okay, so here is a graphical way to show it. It's very easy. You can easily spot that, you know, sodium is also different. Cavendish is higher. You can see the same thing for calcium. Now I look at other information like temperature. At lower temperature, we had more potassium, and here no difference in sodium and no difference, and there's also a difference in calcium as well. So calcium differed between different storage temperature 15 and 25. Okay, and in the peel and the pulp, potassium in banana was higher in the peel, and you can see it here also, as well as you can see the numbers here in concentration. Huge difference between the peel and the pulp. So technically, potassium peel has much more potassium is much more in the peel of banana than it is in the pulp itself. Well, that's what we eat. The same thing applies to sodium as well as calcium, which is usually expected. Okay, and here we have the last thing, my treatment. As I mentioned, my treatment was not significantly different. So you can see here the concentration of potassium across all treatments is not different in all three. Here we go, and this is the interaction. Now we are in the interaction. We are done with this individual mean comparisons for those treatments, and now we are looking at what is like the highest combination. And you can see in the reflection, because Cavendish had more potassium, for example, than milk banana. So in general, as you can see, the output is the same because I asked for interaction. But you can see that there is no interaction actually. So Cavendish under control or under olive oil did not matter. You can see it here. So I'm comparing now 1, which is Cavendish controlled 1, with Cavendish 3, Cavendish oil. So I'm comparing 1 and 3, which is here. It tells me it's not significant. 1 and 2 is not significant. But Cavendish under control and milk control, that is comparing 1 and 4. Here is 1 and this is my 4, is significant. Now, between, for example, say 4 and 5, here is 4 and this is 5, is also not significantly different. That means the variations actually is driven by the cultivar and not by the treatment, and so technically that interaction is not really significant here. And this is what this table shows you, and this is the LS mean distribution for variety by treatment. And you could always look into this table and see what is significantly different from what. So here they are all significantly different from each other. For example, Cavendish peel was significantly different from Cavendish bulb 1 and 2 here. Also, Cavendish peel was different from milk peel 1 and 3. So there's 1 and here's 3. So here everything is different from each other. This interaction is highly significant. So basically, if you look at this potassium, for example, you could see that the concentration of potassium in varieties and also in the peel and the pulp is different. Basically, that's it. This what shows you the interaction and further analysis of your data by using this particular code. One last thing is the graphing. So I'm done with this ANOVA now. I wanted to plot some graphs. You could do that also in SAS. And this is my graphs. And so I'm going to allow this now to work. So this is the setup for graphs. I use the procedure sgplot and the same data sets. I wanted the vertical bar to be variety, and I wanted it grouped by treatments, and my graph will be on potassium. That's basically it. So you could run that, and then you could see it had the potassium, and the varieties are here, grouped by the varieties. This is the Cavendish and this is milk, and you can see it's lower. And this is the code basically for graphics in SAS. This is what I wanted to show you. There are no errors, everything seems to be fine. And so this is the output, and you could do this for all elements, for sodium and calcium as well, which shows a graphical format that you can export later on in any way you like. So that's basically it. You could of course have more than one thing. You know, you could have for example ANOVA and the graphs at the same time. So you could run it that way. And once you have your data analyzed, you can see it here. Okay, you could have this, and you could have the graphs below here as much as you want. You could save this data set in a variety of ways. You could export it as HTML. You could also download it as PDF file. You could just click on PDF and you save your PDF file any way you like. So here we go. I have my data, for example. I have SAS University Edition folders. I keep my folders, all my data in the same file. You could also download it as Word document. You could also print it out, of course, and email it and all of that. But here is, I just want to show you that this is the output in PDF format, and you can have everything here. You could do the same thing in Word, as you can see it here, even your graphics and all of that. So this is basically it. This is how it is, and I hope you are now ready to analyze your data using SAS and explore these options, including the tasks here and different libraries and snippets and shortcuts. It's all helpful, and it shows you a lot of things you can do. You can even graph here using a very simple interface, which is here. It gives you all the codes that you needed. All you have to do is just replace it with the variable that you are interested in, like from here. And I'm not going through this. I leave to you because I wanted just to show you how to code using SAS. And so that's basically it. Very simple, very straightforward. I don't want to take it longer than this already, but I hope this was a very helpful exercise. I'm going to leave this code to you in the description box, so you can copy it and paste it. And you already saw my data sets. You can play around with your own data. Okay, so this is it for this part. Great, we have reached to the end of this tutorial. If you found this tutorial helpful, please subscribe, share, and like it. If you have any comments or any difficulties, please leave them in the comments below. We'll see you next time, and take care for now. Goodbye.